All right.
Miss Fabian, I had the right answer. I just messed up.
I did not scan the right answer. Okay, let's go through this one. So it says PQ is 24. So that means the distance from P all the way to Q is 24. But what am I thinking about as soon as I see that right angle?
12 and 12.
I'm thinking it bisects, so I'm thinking it's actually 12 and 12. Now I am looking for O to M, so that is our X right there. How do I find that X? Yeah.
Do the A squared plus B squared equals C squared.
A squared plus B squared equals C squared, or
Could we do the triples?
you could do Pythagorean triple. And what's our answer?
5.
5. Yep. Either you do A squared, so you do X squared plus 12 squared equals 13 squared, or you know it's a 5, 12, 13 triangle. Either way, I don't really care. If you do this work, awesome. If you just know it's a 5, 12, 13, awesome. You get the right answer. All right, who's the answer for number 2? Yeah.
Is it 45?
Maybe. So if I have these two chords are the same length, I got this one and this one, that means the arcs they subtend are also congruent. So BC, arc BC is congruent to arc CD. So that means you just take 90 divided by 2 and you get 45. Are we okay with 45?
Can you say it again?
Yeah, absolutely. So notice that BC is congruent to CD, right?
Yes.
Since the chords are congruent, the arcs they subtend or they create. So you see this arc
I see.
BC
Half of 90 is
and CD, both of those arcs would be the same length, and so it would be half of 90, which would be 45. All right, today's generally a pretty quick lesson. If you look at it, it's just the first page. That's all we're doing for lesson. The rest will be kind of work time. So we're starting off with, I need to change these symbols. These symbols didn't transfer over very well. So this should be a line. This should also be. It has a hard time going from word to whatever, but that should be a circle. Yeah, Word tries to translate it on my iPad, and it doesn't work always. So CT, so a line is perpendicular to the radius of a circle if and only if the line is a tangent line. So that means any tangent line creates a right angle when connecting to the center of the circle. And down here is our example that we're going to draw. So it says CT is perpendicular to TR if and only if TR is tangent to circle C. So what we're going to do is we're going to draw that situation that's going on here. So we are going to have circle C. And then it says C to T is perpendicular to TR if TR is tangent. So there's going to be a line that is CT. That is that CT right here. And it's perpendicular to TR if TR is tangent. So there's a tangent at T that we got to create. So maybe it'll look something like this. And the name of that tangent line is TR. So we'll put an R there. I think I'm going to move that T. It kind of blended in there. Oh, yeah. I thought you were Steven for a second. I got excited. Okay, so let's finish this sentence. Right now it says CT is perpendicular to TR if and only if. So once again, that double arrow is a shortcut for if and only if. That means it goes both directions. TR is tangent to circle C. So that means this is a tangent. This goes to the center. So this must be a 90-degree angle. This will always be 90 degrees. So a tangent line or a tangent point, when connected to the center, makes the tangent line perpendicular, creates a 90-degree angle. That is pretty important. 90 degrees are always nice to be able to pull out because then you actually know a measure of a degree. All right, number 2 says 2 segments drawn from the same circle that intersect outside the circle are congruent if and only if they're both tangent to the circle. I think I want to move this up a bit. Let's see if we can find it really quick. That was pretty low. I got it right here. Thank you, though. I actually saved those slides. All right, I bumped it up a little bit. So this says that line AG is congruent to BG if and only if AG and BG are both perpendicular to, and that should be circle D. So what a picture of this is going to look like. So we need a circle. We need a circle, and it says it's circle D. All right, now we need a line AG and BG that are both tangent to the circle and both meet outside the circle at a point G. So let's go ahead and make a point G out here. We'll call that G. Now we're going to have a line that's tangent to the circle that would look like this, and a line that's tangent to the circle that looks like this. This is going to be AG and BG. So we'll call that A. We'll call that B. So if both of these lines are tangent, which they are, they hit at A, they hit at B, and if those two tangent lines meet at a point out here, that means the distance from A to G and the distance from B to G are congruent. So AG is congruent to GB, or BG and AG. This one's a pretty important one. It shows up in the homework a lot. You have to just notice, if I have two tangent lines that meet at a point outside, you have to immediately go, hey, those two things are the same length. That's going to be the only way you can answer a whole bunch of the homework. Yeah?
Couldn't it, like, not be the same length if it was, like, you know, like point G was shifted down more?
Doesn't matter. Because if I shifted G down, so you can kind of picture this, it would just move like this.
Well, no, I mean, like,
the lines would stay there.
But, like, leave the circle. You know what I mean?
Like move it down.
Point
more
G itself would remove.
But then they couldn't both be. If I move G down, A and B would have to move as well. Because once you pick a point, and you kind of draw a picture and understand kind of how this is working. So if I did G way down here.
I forgot it only takes it once.
But it has to be, they have to be tangent to that line. So as G moves down, there's no other way to draw it without making them look congruent. And in fact, they will be congruent.
I forgot they only touched once.
Yep. It is that rule. So it kind of looks like you can move G down and we have like different lengths. But as soon as you move this down, it actually has to rotate A and B. So it'll always be this way. There's no way to draw it differently. Does that make sense, though?
Yeah.
Grace, does that make sense to you? That you can't move it and change those values? All right. Any questions on this one? Like I said, this one shows up a lot and is kind of buried in there. Also, remember, this is just kind of a review, that if I drew this line from the up above, this would be a right angle. If I drew this line here, this would also be a right angle based upon the one right above it. Yeah?
So that would also, you could also say that AD and
B
are correct.
Yep, and you'll come up with that. But we don't have a standard theorem for that, but it is true. Okay, we all go with both those. Those are the two big ones you're going to use today. Let's go ahead and practice it really quick. So like I said, this is what you should be thinking of. As soon as you see this picture, you see this point out here, and we can see that both of these lines are tangent. As soon as you see two tangent lines connecting on a point outside without even looking at any part of the problem, I'm just going to immediately say, well, that's congruent to that. I'm going to immediately say that is congruent to that because they're tangent and they meet outside automatically. That's what your brain needs to think immediately. Whew. What can we do now? Akshay.
180 minus 36 divided by 2. To find like find the congruent sides for the angle.
Well, we could do 180. And then you said minus
36.
36. And what's that going to get me?
144.
But where is that going to get me, though, I guess? Because do we know these two angles? If we know these two angles, then we're solid. Hannah?
You can turn that into an isosceles triangle, and the 144 divided by 2 is the two base angles.
Where am I drawing isosceles triangles? So do you want to draw it like this?
Yes.
Okay. There's a much easier way, because this will get us this angle, but we're still going to not know these angles. We might. We just have to come up with one important fact. Evan?
Go from egg to 36, and then you know that the top and bottom angles are 90.
We do know the top and bottom angles are 90. That's the key one I want to talk about.
And then the angle 36, you split that in half.
Yeah, that is one way to do this. There's another way to do it. So we know that this is 90, and this is 90 because we have a tangent line that's connected to 0. So this is 90, 90. Now we could kind of do what Akshay was saying, or we can do what Evan said. Akshay, I think you were trying to come down to the fact that there's 360 degrees in a four-sided figure. Now we can do 360 minus 90 minus 90 minus 36, which will get us our answer. That is one way to do it. Evan's way is 100% valid too. What Evan said to do is, well, we can just do this. We know that this is cutting that angle right in half. So this would be 18 degrees. And then we just do 180 minus 18 minus 90 will get this one, and you just double it. All right, so your way works 100% fine. I'm going to go ahead and do Akshay's method because that's just plugging in the calculator. I don't have to draw pictures. But Evan, stick with your method. That's great. There'll be times where that's what you have to do on these problems. But I'm going to go with Akshay's way, where it's 360 minus 36 minus 90, or 180 minus 90. And what does that come out to? Yeah.
144.
144. Did we all get it? 144? What was that? Yes. Both of them should get the same answer. I always make sure, is everyone, yeah.
So is it significant that that's the supplement of 36, or is that just a coincidence?
That is the supplement. No, we're going to talk about that tomorrow.
Okay.
Yeah, but it's not really a coincidence.
Can we use that, like, to solve them? Or
Don't.
not yet?
Realistically, we're going to come up with a theorem where if it's inside this circle, then they're going to be, but it kind of works like this, all right? But be careful with it. All right, number 2. What's the first thing I need to do? Yeah.
Sorry. See if the lines are like tangent, and they are.
Are they tangent? Do they meet on a point outside of it? Yeah, the lines are tangent. Do they meet at a point outside the circle? Yeah. So that means they are congruent. So this is congruent to that. Well, that's an isosceles triangle, right? Yeah, Evan.
Oh, wait. So I just have a hypothetical question. It's about this problem.
Okay, can I finish the problem?
Yes.
And then we'll do the hypothetical. All right, so if it's an isosceles triangle, the base angles of an isosceles triangle are congruent. So that's going to be 48. This is going to be 48. So if that's 48, that's 48. What's B equal? You already helped me on part of this one. I'm looking for someone else. Sabrina?
Would it be, it would be 94, wait, no, 80, wait, yeah, 80, wait, yeah, 80, yeah, 84?
Are we okay with 84?
180 minus 96.
Yep, it's going to be 84 because 48 plus 48 is going to be 80 plus 16, which is 96. 96 plus 4 gives you 100, and plus 80, so it's got to be 84. Yep, 100% right. So your goal isn't to immediately recognize that if there's a point, if there are two tangent lines that meet at a point outside, then it creates congruent lines. Also remember that if it meets at the center in a tangent line, those are 90 degrees. All right, hypothetical.
Would we ever be given like a problem like this without like angle measure 48?
No.
And then, okay.
You would need at least one angle measurement
what
to
I
start
was
that off.
thinking is if, like, could we, like, what would happen if, like, would we ever given one that would be, like, would we have to draw in, like, the center point out to the tangent or not?
Possibly.
And then,
It really wouldn't help us here
well, that's why I'm asking, I'm just,
because we could draw this out, and I see where your mind's going that this is 90 degrees. That somehow that would help us figure out this angle.
well, no, I'm not saying for this specific problem, but
Right.
like for, like, future problems, will we be given one with, like, no 48, where we have to draw that, even though it's 90?
Possibly. I'm not going to say that it can't happen. I'm not thinking of one offhand that I made you do that, but it's good to know, right?
Yeah.
It's definitely good to know. All right, that is it for today's lesson. Let's go over questions from the homework. Yeah, Evan.
28.
Number 28. Okay. So 28 says X, Y, and Z are points on circle P such that triangle X, Y, Z is equilateral. If the radius of P is 6, what is the perimeter of X, Y, Z? All right, so what we're going to do here, I think I actually have it up here. No, that's 23. Oh, I can do it. Well, there we go. Okay, so points X, Y, and Z are points on such that X, Y, Z is an equilateral triangle. So let's go ahead and draw our circle. Let's go ahead and draw our semi-equilateral triangle. And this would be our X, Y, and Z. Well, what I want to recognize is the fact that it says its radius is 6, right?
So, like, P to Y.
So here's the big important part, is if I go from here to here, that is 6. If I go from here to here, it's 6. If I go from here to here, it is also 6. All right? But now, if I cut this triangle, if I cut that triangle like that,
Oh, yeah, 90.
I'm going to create a 90-degree angle. And more importantly, since every angle of an equilateral triangle is 60 degrees, this inside of here is going to be 30 degrees. This will be 30 degrees, which will give me a 30, 60, 90 degree, which is going to let you find this. And if I'm looking for the perimeter, it'd be just X plus X plus X plus X plus X plus X. In other words, whatever X is times 6 will get you that answer.
Wouldn't it be-
So
oh, wait, yeah,
this
but
would be
I was
X.
thinking- I was thinking of 2 with X square root 3.
This would be X. That would be X.
Yeah.
This would be X. So there's actually 6 X's. So as soon as you find X, and you feel free to do it, you should come up with, what did I come up with? 3 square root of 3 when you do it. Is that good?
Yeah.
I think the key is that 60 degrees, and ask yourself, why did they tell me the radius?
Yeah, I didn't like get what's
And what I kind of do whenever they give me the radius is I just kind of think about where I could put it. Well, if I put it here, that doesn't help me much. If I put it here, it doesn't matter. But all of a sudden, I'm like, boom, okay. You know, at least it's something you can draw. You're like, hey, Mr. Pavian, on a test, I know this is important to draw the radius like this. I don't know how to use it. But at least that drawing can get you more points than just not having the radius in there.
The thing I didn't know is that I didn't know that we could do like the draw the little line.
Yeah, that's a tough one.
That's what
And that kind of comes back to, remember on our other test where I said anytime you have an isosceles triangle, your first step should be divided in half so you create a right angle. Isosceles basically tells you split me in half.
Then there's like 26 and 27 the same thing.
What was that?
I think 26 and 7. 26 and 27 are the same thing.
Yeah, maybe. I'm just going to go to someone else if they have a question, then I'll come back to you.
Yeah.
Other questions? Lydia? Oh, there you go. See? So 27 says, in circle T, diameter BC is perpendicular to chord MN, intersecting at point E. If TE equals 8 square root of 3 and the measure of the arc, I believe it's the arc, BN, equals 150, then what is BN? C. So let's go ahead and draw what's going on here. So first of all, I have circle T. So let's start with circle T. All right, we have circle T. And then it says diameter BC is perpendicular to chord MN. So we're going to draw BC. Well, we know BC is a diameter. So it's got to run through the center. This is my diameter BC. Is perpendicular to chord MN. So this can be, so it has to be a chord that's 90 degrees to this. It doesn't say it's a diameter. If it was a diameter, it would say it's a diameter. So it's got to be past at least here, right? You could have drew it here, 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 here. I'm just going to do it over here because it kind of matches all the other stuff we're doing. So that is my perpendicular chord M, N. And since it's perpendicular, we're going to draw a right angle here. And as soon as I do a right angle there, what should I think about MN? And let's put the point E here. So before I go any further with just this drawing, what does this right angle tell me to think about MN? Yeah, so I would just probably do that right off the bat. I'd go, I don't know what they're asking me, but I'm guessing this is important. All right, so as soon as I drew that right angle, knowing it's perpendicular, okay, now it says that TE equals 8 square root of 3. So this right here is 8 square root of 3. And then it also says BN is 150 degrees. So that right there is 150 degrees, right? Make sure, yeah, we got 150 degrees. My drawing's looking pretty snazzy. All right, so here's kind of the hard part about this. And it is the fact that anytime we have something that looks like this, your natural instinct should be to create this right triangle. All right, why I'm creating it right here is because this is an in-center where the arc at subtends is 150 degrees. And since that's 150 degrees, let me erase this T and move it somewhere else. This actual angle is 150 degrees. So that would now make this 30 degrees, right? This would make 30 degrees. Let me see what they're looking for. They're asking for the length of BC. So I'm going to pull out this triangle. I'm going to pull out that triangle. Do we all see that triangle I'm talking about? If you're on this problem with me. So I'm pulling out this triangle here so I can write a little better on it. This is 8 square root of 3. This is my 90 degrees. Maybe I'll label it as T, E, N, 10. And this is 30 degrees because this was 150. Well, if that's 30, this is 60. All right, the question was number 19. Well, 19, what we need to recognize is, see how this is 95? Yeah. And we're looking for these. I'm just going to put 95 out here as well. This measure right here is 95 degrees. Well, then I'm going to look at this chord is equal to that chord, which means C, whatever this arc is, maybe I'll do it in purple.
Oh, so would you just do 90? Would you add 95 and 17 and then subtract that from 360?
360 and then divide by 2, because we have two C's, right? Yep, you got it. Other questions from the homework?